Here I will start discussing the remaining two problems. Okay, problem number 5, because we already discussed the problems from 1 to 4. Okay, the electrical resistivities of 4 materials A, B, C and D are A 6.84 into 10 to the power minus 8 ohm meter, B 1.70 into 10 to the power minus 8 ohm meter, C 1.0 into 10 to the power 15 ohm meter and D 11.0 into 10 to the power minus 7 ohm meter. Which material can be used for 1. Making heating element of an electric iron, 2. Connecting wire of the iron and 3. Covering of the connecting wire. Okay, now see which is the for question number 1, heating element of an electric iron. For that we will be using the element D. D should be used for heating element because it has very high resistivity but not as high as an insulator. Out of these 4 elements, only one has a very high resistivity of the order of 10 to the power 15, that is an insulator. But this has a high resistivity but not as high as an insulator. So this should be used for heating element. So D should be used for heating element. Now what should be used for connecting wire of the iron? Connecting wire means it has to be a good conductor. So which has the lowest resistivity here? And the lowest resistivity is element B. So B has the lowest resistivity. So B should be used for connecting wire because it has the lowest resistivity. Now which should be used for covering of the connecting wire? That means that has to be an insulator. So which has the highest resistivity? C. C should be used for covering of the connecting wire because it has the highest resistivity. Because it is an insulator. Now let us go to the numerical problem number 6. A 220 volt iron at minimum heating position consumes 360 watt and at maximum heating position consumes 840 watt. Calculate the current and resistance in both cases. So let us separate it out, one for the minimum and one for the maximum. This is the minimum and this is the maximum. Now at minimum it is 360 watt, P equal to 360 watt. Voltage is anyway 220 volt in both cases, and at maximum it is 840 watt. So P equal to 840 watt when it is in the max position, and voltage equal to 220. Okay, we have to calculate the current. Formula is P equal to V into I. So we know the value of P, that is 360. Okay, I equal to P upon V. P is 360 and V is 220. 360 by 220. Let us find out what the value is. Which comes to 1.64 ampere. So current flow for minimum position is 1.64 ampere. In case of maximum, I equal to P upon V. Here P is 840 by 220, which comes to close to, I think, 1.8 or maybe 1.9. Let us see. 840 by 220 equal to 1.82, which is coming to 1.8. Sorry, 3.82 ampere. Yeah, 3.82 ampere. Okay. Now, so I'm sorry again. It is 3.82 ampere. In maximum position, current flow is 3.82. Now again, for minimum position, resistance should be calculated from the Ohm's law. V equal to IR, that is 220 equal to 1.64 into R. Therefore, R equal to 220 upon 1.64, which is coming to 1.64, which is equal to 134.2 ohms. So, for in the case of minimum position, we got the current flow as well as the resistance. Now, for the maximum position, current flow resistance can be obtained again from the same formula, R equal to V upon I, that is 220 by, here the resistance is 3.82 ohms, and 220 by upon 3.82, it comes to 57.6 ohm. So, that is all. So, we got all the answers. So, this was the last problem of current electricity.